So now that we understand the ray model of light a little bit better, what we're going to be doing now is we're going to be using those principles to locate images in mirrors. We've already looked at locating an image in a plane mirror. That's a little bit easier. Now we're going to look at locating an image in a curved mirror. So curved mirrors are going to throw light back in different directions. It's going to be a little bit more complicated. We're going to start with an introduction. So we're going to start with the different types of mirror. The first type of mirror that we're going to look at, we call it a concave mirror. It can also be called a converging mirror. So we've got a picture here of our concave mirror. I always like to remember it because it kind of looks like a cave. So notice that we have these lines at the back here. What these lines represent is it represents the back of the mirror. So it's meant to remind you that behind a mirror, it's actually solid. It's actually painted black. So there's no light that's actually traveling through the mirror. What's happening is the light is hitting this reflective surface of the mirror and it's bouncing back in this direction. So no light is actually going to travel back here. So a concave or a converging mirror, you can see the center of the mirror, which is here, is going to bulge away from you. So if you picture yourself standing on this side of the mirror, the center of the mirror is converging away from you. So if you've taken a really good look at a car headlight uses a concave or a converging mirror. It bulges away from you. A flashlight also has a converging mirror. And then your makeup mirror. You probably never realized before that your makeup mirror is a curved mirror. Now, obviously, it's a very subtle curve. It looks like it's flat. But the fact that it's able to make images look bigger or smaller means that it's a curved mirror. Your makeup mirror is also a concave or a converging mirror. The other type of mirror, and we're going to look at this in our second lesson, is called your convex or your diverging mirror. So again, if we look, this is the back part of the mirror with these lines. No light's going to travel out here. So in a convex or a diverging mirror, the bulge is actually towards you. So again, picture yourself as a little stick person on this side here, right? The mirror is bulging out towards you, and the thinner part is away from you. These are like security mirrors. If you've ever gone into a store and you've seen the big mirrors up in the corner and they look rounded towards you, that's a converging mirror. Or also the mirror on the side view of your car. If you notice at the very bottom, there's a kind of small mirror. My dog is saying hi, sorry. There's a little tiny small mirror in the corner. It bulges out towards you too. That's also a diverging mirror. A couple terms that are going to matter for both types of mirrors, converging and diverging. The first term that matters, we call it the center of curvature. So remember, we're now dealing with curved mirrors. So it's not straight, it's curved somewhere. That curve has got to come almost like the slice of a circle, right? So the idea of center of curvature is if you were to recreate the mirror as a circle, the center of curvature would be the dot right at the middle of that circle. So the center of the sphere used to make the circle, rather than having to write out center of curvature all the time, we just use the letter C to represent it. So C represents center of curvature of the center of that sphere of that mirror. We have another term we use with curved mirrors, and that's called the principal axis. The principal axis, let's move my face down here. There we go. The principal axis is a line through the center of curvature that meets the midpoint of the mirror. So just like we used the word normal or perpendicular before, we want to use that normal or perpendicular to draw our light rays. So the principal axis, you can see we've got the center of curvature here. We've got the midpoint of the mirror here. The principal axis is just that line, that parallel line that connects the two. We also have something called the vertex. The vertex is the point at which the principal axis intersects the mirror. So we use V to represent vertex. You can see this vertex, as soon as that principal axis has touched that mirror, we have that V right there. So before we get too far into talking about concave mirrors, there is a label diagram that I want you to go ahead and label. It's a Google Doc. These terms are going to be really important. We're going to keep learning these terms, and there's going to be one more term that we're going to add in a second. That's going to be the focal point. So make sure you have this diagram labeled. Make sure that you've labeled the link diagram because we are going to come back to it. Now let's start by talking about our concave mirrors. Remember, concave mirrors are the same as converging mirrors. So in a concave mirror, you can actually locate the focus. You might have heard of the term focus or focal point before. Any light rays that are parallel to the principal axis are going to reflect off the mirror through a single point called the focus. So the idea here is we're going to have light rays coming in and hitting the mirror. Any light rays that are parallel to this line here are all going to come through the exact same point on the principal axis. So let's take a look at this using one light ray. We have one light ray come in, and this light ray is going to reflect back. Now remember, this is a curved mirror, not a straight mirror. So this is going to reflect back, not necessarily at the angle of incidence, because it's a curved mirror. It's going to reflect back through this point right here. So we've got our incoming incident ray, we've got our reflected ray, and notice that it's crossed this point on the principal axis. Now let's take a look at another light ray. We have another light ray, this time on top of the principal axis coming in. It's again coming in parallel. That light ray is again going to bounce off of the mirror. It's going to bounce off of the mirror here. Notice these two reflected rays are crossing, no matter where their incident rays were shone, at the top or at the bottom. The two reflected rays are crossing through the same point. We call this point the focus. So you can actually locate the focal point of a mirror by just shining a bunch of light rays in. Wherever those light rays bounce off, you're going to see them crossing. That's going to be the focus. So again, if we take a look at another light ray coming in parallel, that light ray is going to come out through the focus. All of these lines crossing here, we call F, we call the focal point. One thing to note, and this is really useful to write down, the focal point is always halfway between the center of curvature and the mirror. So this distance here is the exact same as this distance here. So if you know the focal point, if you know the exact distance of the focal point, you can figure out what your C, center of curvature, is. Let's give you an example. Let's say that you use a bunch of incident rays and you're able to locate what the focal point is. Maybe the focal point is 10 centimeters away from the mirror, then you know your center of curvature is automatically going to be 20 centimeters away from the mirror, right? This is 10 centimeters here, and then this here is going to be 10 centimeters. So you can actually visually see your focal point, and then your center of curvature can be located as you take your focal point, you go ahead and double it, and that's going to be where your center of curvature is located. Because the concave mirror focuses the parallel rays at F, this is why it's actually called a converging mirror. So it's called converging because it takes the light and it bends it inwards, right? The light is coming in parallel and it's bending inwards towards a focal point. That's why we call it a converging mirror. That's where it gets its name from. All right, we have 4 incident ray rules that we're going to look at. So these incident ray rules are going to take into account C, and F, and V. So we have a couple rules that based off of curved mirrors, these light rays are always going to follow. Let's take a look at our first rule. It's color-coded in red. A light ray coming in parallel is going to be reflected through the focal point. We already know that. That's actually how we discovered what the focal point was. So rule 1, anything coming in parallel is going to be reflected through the focal point. Let's take a look at rule 2. Rule 2 says that a light ray coming through C is reflected back onto itself. So any light ray that's coming through C is going to hit the mirror and actually be reflected back directly on top of itself. You can't really see it in this image because the 2 light rays sit on top of each other. But if you take a look at this line, forgot what that was called. If you take a look at this line, you've got an arrowhead on this side and you've got an arrowhead on this side. That's suggesting that this is both the incident and the reflected ray. So if we take a look at both of these together, we can see our 2 rules on the same diagram, coming in parallel, going through F, and then bouncing back through C. Our third rule, which is going to be in green here, says that a light ray through F will be reflected back to the principal axis. So at first glance, this diagram might look exactly like rule number 1, but if you take a look at the arrowheads, it's actually different. We have a light ray now coming through F, hitting the mirror, and it's going to come out parallel. Well, this is what we would expect, right? A light ray coming in parallel comes out through F, just like a light ray coming in through F is going to come out parallel. So rule number 1 and rule number 3 are kind of like opposites of each other. So again, if we're going to look at all 3 rules to recap, I come in parallel, I go out through F, I come in through C, I go out through C, or I come in through F and I go out parallel. My last rule has to do with V, the vertex. You can see it in yellow here. This says that a ray aimed at the vertex will follow the law of reflection where the angle of incidence equals the angle of reflection. So remember that before, any light rays that were hitting anywhere else in the mirror weren't following this rule. That's because this is a curved mirror. However, the exact point at which the vertex is, this exact point here, this is considered to be a flat or a plane mirror. So this part here is considered to be almost a flat mirror. So for this exact instance, for this exact vertex, your angle of incidence is going to equal your angle of reflection. It's going to follow those plane mirror rules. All right, so now that we have our 4 rules, who cares? What do these rules matter, right? So we're actually going to use these rules to show you how to locate an image in a plane mirror. Now, to locate an image, we actually are going to need to put an object, right? You're not going to see anything in a mirror unless you have something in front of it. So we're going to be placing an object now, and we're going to be using these rules to look at an image. Now, to locate an image in a mirror, you need to draw at least 2 incident rays. I like to say draw 3. 2 is a bare minimum though. The reason you need at least 2 rays is because an image is always going to be located at the point in 2 reflected rays where they cross. So as soon as you see 2 reflected rays make an X, I say X marks the spot, you know that you have an image. If you only use 1 ray, there's no possibility to have those 2 reflected rays cross. So you need at least 2 rays. You can make it happen with 3 rays. You can actually make it happen with all 4 rays in some cases based on those rules. So we're going to start by drawing just our setup. We're going to start where we have a curved mirror. We have our principal axis. Notice that we have our center of curvature and we have our F. Now, this doesn't actually work if you sketch it. If you sketch it, it's not going to follow these rules. You need to make sure that F is exactly halfway between C and the mirror, right? Remember that F is halfway between C and the mirror. C is twice as far out as F. So I've actually gone and I've measured this diagram right here, and we've placed our object. You can actually see our object. We're just going to use this arrow as an object. I know it doesn't seem like a great object, you know, a cute little cartoon might be better, but the really nice thing of using the arrow is you can really easily see if the size of the arrow is different, if the attitude of the arrow is different. And remember, at the end of the day, we're going to be using SALT to describe our image. So step 1, I'm going to start with my first rule, and I'm going to have a light ray is going to go in parallel. Now, this is usually the first mistake that students make. They'll draw a light ray going in parallel, but they'll draw a light ray like up here. That doesn't make any sense. You need to make sure that your light ray that you're going to be drawing is coming from the top of your image. So if you've got a ruler at home, that's what you're going to use right now. If you're using the computer program, Google Draw, you can use that as well too. You're going to have your straight line start touching the top of your object. So notice the straight line starts touching the top of my object, and then I draw in a totally parallel line hitting the mirror. As soon as this line hits the mirror, you're going to see this, the reflected ray is going to bend. It's going to bend, and it's going to bend coming through F. Because remember, anything with an incident ray going parallel is going to come out through F. So we now have one line drawn here. We're going to go ahead and we are going to draw a second line. I like to rely really heavily on rule number 1 and rule number 3. Most of the time they're going to work, and they're the easiest ones to use. So my second rule, let's zoom out so you can see this whole thing here. There we go. That's better. My second rule, I've again lined my line up with the top of my object. So I didn't start drawing a line up here. I didn't start drawing a line down here. I've taken the butt of my line, I call it the butt, and I've lined it up with the top of my object. I then use my ruler or my straight object to take it from the top of my object. I'm going to go in through F, and I'm going to hit the mirror. The second that I hit the mirror, I'm going to have this light ray be reflected. And how is anything coming through F? It's reflected back parallel. So notice that these lines, these reflected rays, I actually extend them quite a ways. I would actually, if I was doing this diagram and not knowing the outcome, I would reflect them even further back because we're waiting for them to cross. Remember, this is a converging mirror, so our reflected rays are going to converge, and I can see the X marks the spot, that's hard to say, right here. So I can see this exact spot right here. This is where my image is going to be located. So the next thing I'm going to do, I'm going to actually draw my image in. So where the image is located, I'm going to draw in my image. Notice all I've done is I've started underneath the object, and I've drawn an arrow right to where my lines cross. I now want to compare my image, this line, to my object, this line, so I can describe salts. So I'm going to take a look and I'm going to see for the size. If I actually look at it, they look like they're the same size. So S, I say same size. This is upside down, so that means it's an inverted image. For location, I want to be as specific as possible. So this dot, or this line, is exactly at C. So I'm going to go ahead and I'm going to say at C. If it was here, I would say between C and F. If it was here, I would say beyond C. If it was here, I would say between F and the mirror. So you always want to use those reference points. You always want to use C and F and the mirror as reference points to say exactly where your image is located. Lastly, I know I've got, let's go back to my pointer. I know I've got a real image. How do I know I have a real image? I have real reflected rays. These are two real rays that are crossing. Remember, a virtual image is anytime I need to use those dotted lines. And a virtual image is actually always going to be located on the other side of the mirror. In this case, we didn't have a virtual image. We had everything's in front of the mirror, so we have a real image. Now, those rules are always going to work. They're a little bit tricky, though, to get them to cross the first time. So I actually gave you a lab this week where you're actually going to be using these rules to see if you can get the lines to cross. So I put the object in several different places. I put it beyond C. I put it between C and F. I put it at F, and I put it between F and the mirror. I want you to use these rules each time to get it to work. Now, sometimes one rule might work. I'll give you an example, or might not work. I'll give you an example. If you have an object here, there's no way that you can actually take your ruler, line it up with the top of the object, and then line it up through F. It's just not going to work. So that's why we gave you 4 rules. Most of the time, these 2 rules, going in parallel, coming out through F, and going through F, coming out parallel, are going to work. Sometimes you're going to have to use rule number 2, and sometimes you're going to have to use rule number 4 to get it to work. Again, if you're having trouble actually figuring out how to get these lines to cross to figure out where your image is going to be, I gave you a lab simulation as well too. So that lab simulation, you're actually going to be able to play with it so you can actually see exactly where your image is located. That'll give you a nice little hint. And then you're going to use at least 2 rays to show me where the rays cross. Once you've done this assignment, we can tell you that it's actually almost like cheating a little bit. We're letting you cheat because you're actually always going to know the answer. I now know that anytime that I have an object at C, this is always going to be my salts. You're going to determine the salts for the other types of objects, and then we are always going to know where our image is going to be located based off of the object. So I'm making you do all the hard work. That's okay. So you're going to be working on that lab for me this week. That lab is based off of just converging mirrors. Tune into the next video, and I'm going to deal with diverging mirrors separately because they're a little bit of a separate beast. Good news is there's only one type of image that a diverging mirror can form. It's just a little bit more complicated. So whenever you're ready, go ahead, take a look in the next video, and we're going to discuss diverging mirrors.